Okay. Assalamualaikum and very good morning to everyone. Okay. Um, Again, like what Ibu Asri just said, please don't be worried, so worried. Okay, we can speak in Bahasa and also English. If you have any questions, please do so. Okay, maybe Ibu can help to translate it better. Um, okay. All right. So my name is Nadiah Abdul Karim Shah. You can call me Nadiah or Dr. Nadiah, whichever is okay. I've been a lecturer at the Department of Process and Food Engineering, University Putra, Malaysia, for about close to 8 years already. Okay, since 2015. I have several industrial experiences working with Nestle, working with a small medium company, and also with fine dapple plantation. Okay. My expertise are actually non-thermal in non-thermal food processing, but thermal food processing on the innovative part, I have a bit of experience in that field also. Okay, so for today, we will be learning about spray drying and drum drying. Okay, so the learning outcomes or the objective of this session is for you to be able to understand the principle and mechanism of spray and drum drying and to be able to differentiate between spray and drum drying and also to know the important parameters, okay, in spray and drum drying technologies and it is successful implementation in producing seafood. Okay, so these are a couple of references that I've used, okay, on the handbook of spray drying and also on the advanced drying technologies for food. So as an introduction, okay, drying is one of the oldest food preservation methods. Evidence have shown that since early 12,000 BC, in Middle East and Oriental cultures such as China, Japan, have actively dried foods in the hot sun. And the removal of nearly all the water present during vaporization is known as drying or dehydration method. Okay, so basically what we want to do is to remove all the water inside the food to be as nearly as dry as possible. Okay, we call it bone dry condition, something like kering seperti tulang. Okay, so bone dry material is the material from which all the moisture has been removed. So drying is carried out for one or more of the following reasons. Okay, to eliminate moisture which may lead to corrosion and also to decrease and that can also decrease product stability. So basically, we want to improve the food properties of material. We want to see flowability of our food product, compressibility, okay, and to reduce the cost of transportation so that product will be easier to handle and also to increase the shelf life. That is the ultimate. Okay, so if you look at the food preservation method, okay, so drying is under the inhibition, meaning we try to inhibit the growth of microorganisms. Okay, if you could see down here, drying is one of the preservation methods. But drying, we have a lot of methods, yeah. I think you guys have gone through with Ibu Asri lectures, and what I will be covering today is only on the spray and the drum drying. So the goals of drying is basically to minimize chemical and biochemical degradation reaction, to obviously selective removal of water. We only want to extract the water out, okay? But the salt, volatile flavor, and the aroma compound has to be retained within the food because we want it to be as close to fresh food as possible. And of course, we want to maintain the product structure if the food is structured. Okay, sort of like if you have fish, we want to retain the shape and the size of the fish itself. So that is why we use drying as a preservation method. We also want to control density, the density of your powder, okay, to make it more easier to be transported, okay, easier to be packaged. And of course, we want to minimize risk of contamination from bacteria for adulteration, meaning, for some people to use your food to sabotage, to make into fake foods. And of course, to increase the storage life of numerous product materials and to minimize product loss. So with the dawn of the industrial age, many different drying processes have been developed to increase drying speed, okay, and to improve product quality and uniformity. So if you look at this here, this is an overall view of a supermarket where you could see there's a lot of dried product on the shelf. Okay, they are all boxed, and we have, pasta, we have bread, we have a lot of powders in terms of flour, milk. Okay, so all of this, what you have seen here, has gone through some sort of a drying process. Okay, so why we want as many products as possible because of the higher income, urbanization, okay, demographic shift, improved transportation, consumer perception. Sometimes they prefer more dry product over fresh product because they could keep it for a longer period of time without damaging the quality and the safety of it. Okay. So ultimately, the consumer would want healthy, safe, and less processed food, okay, that are in demand with today's society. Okay. So before we go any further, I would like to just focus first on the definition of drying and evaporation. Okay, so drying process is mainly on solid material. Okay, and drying is basically the removal of relatively small amount of water from the solids. But when talking about evaporation, it's basically a removal of large amount of water from solution. Okay, so that's the difference. The main difference, drying is from solid and evaporation is from solution, and drying only a small amount of water, but evaporation a large body of water. Okay, and another thing, the differences between drying and evaporation is that drying removes water at a temperature below the boiling point. But for evaporation, the temperature has to be above the boiling point. Okay, so you're talking about boiling point of water is going to be 100 degrees C. So the evaporation or extraction of water has to be above the boiling point, which is 100 degrees C. Okay, and another differentiation between drying and evaporation is drying is usually done by circulating air, okay, over the material to carry away the water vapor. But for evaporation, water is removed from the material as a pure water mixed with other gases. Right? So there are 4 differences between drying and evaporation. So for today, what we are dealing with is basically evaporation of our food product. Okay, so the first one, we're talking about spray drying. So the overall view of a spray dryer looks something like that. Okay, this one is in industrial setting. So the inventor of spray dryer is actually this guy here, Samuel R. Percy. Okay, so this guy invented the spray dryer for the objective to spray dry milk untuk susu. Okay, untuk susu during the World War II. So during the World War II, a lot of invention came out from that because they want to send their military overseas, but those military have to eat, okay, and they cannot get sources from the local source, so they had to bring food from their country. So that is why they started to innovate a lot of technology that they could to process their food products so that they can bring overseas and for their military to eat, right? So if you look at the future forecast for spray drying, so the compound annual growth rate for spray dryer, we are looking at 6.8 billion USD in 2027. Okay, in comparison to 5.1 USD in 2022. This is because we have a lot of expansion in terms of the pharmaceutical applications. Okay, we look at the micro encapsulation advancement using the spray dryer and technique in the agrochemical, okay, in the pharmaceutical industry, and also on the processed food and ready to eat food. Okay, so the growing demand is getting higher, okay, and it offers lucrative opportunities for the market players in the next 5 years, right? So that is why it's very important for you guys to learn about spray drying, right? So this is the principle of spray drying. This is what a spray dryer looks like. Okay, this is for lab scale. We have this in our lab. We use this to dry a lot of products. Okay, fruit juice mainly. We also dry a lot of tongkat ali extract. You guys are familiar. We also have dried ginger, turmeric. Okay, we have also dried a lot of other products such as coconut water. We have done that. Okay, so the aim of spray drying is basically to produce powder from liquid with a specific particle size and moisture content. So spray drying is a method of producing dry powder from liquid or slurry or by rapidly drying with a hot gas. Okay, so it needs a very hot gas. And preferred method of drying many thermally sensitive materials such as food and pharmaceutical. Our food product has a lot of vitamins, and those vitamins are very heat sensitive. So that is why we use spray drying to retain as much as of the vitamin as possible. Okay, so consistent particle size distribution is the reason for spray drying industrial products such as catalysts. Okay, we want a uniform particle size. That is very, very important in spray drying. Okay, we will discuss more later as you look at the slide. Right, so air is the main heated drying medium. However, if liquid is flammable, like when you are dealing with industrial catalysts, enzymes such as, okay, if it's a flammable solvent such as ethanol, so we use nitrogen instead of air. So the advantages is that we can produce a lot of types of powder with different particle size. Granulometry meaning different characterization of powder. Ada yang kasar, ada yang lebih halus. Okay, so those are the types that we want. Okay, and we also produce different types of powders with different density. Okay, for instance, we're talking about instant coffee. Okay, so that is the property that we want with the limited water activity, right? And a lot of fluid. Okay, we call this feedstock, right? So a lot of fluid in terms of solution, suspension, emulsion can be spray dried using spray dryer, and the temperature and contact time can be adjusted to preserve the bioavailability of your product. So if your product, for instance, egg powder has a lot of albumin, protein content, acid amino that comes with it, that may denature in a very high temperature, and you can use spray drying instead because the control ability of the temperature for spray dryer. Okay, and the quality of the dried product is enhanced by the spray drying method. So we can also get consistent and superior product quality, and the product that comes out of the spray dryer is very hygienic. And we also have a very good level of stability and relatively long shelf life because of low water activity. They are very easy and very convenient to store and also to prepare. And one thing that is very, very good about spray drying method is that the product will undergo very little browning or lipid oxidization process. And whatever the product that you get, like for instance, milk product or instant coffee product, if you dissolve in water, you would definitely get the original quality of the product, the initial product. Okay, so basically kalau you keringkan coffee, bila you campurkan dengan air, kita panggil resolubilization, dia akan dapat semula karakter coffee yang sebenar. Okay, so this is one of the example. Okay, spray dried lactose, which is milk. Okay, by using a flow let go, this one at 90, you can get a very small particle, and this one is even smaller, right? So another thing that is very good is that spray drying is a continuous process. It can handle a very large volume, application to over 100 tons per hour for a very large application, and with very high efficiency. And the best thing about that is that you use a very short time. So it can be completed within less than 3 minutes. Okay, you can get each powder. You can get milk powder, strawberry powder, coffee, orange. There's a lot of product that you can build with this spray drying. Okay, and so since drying time is very short, it helps to protect heat sensitive material and reduce energy consumption of spray drying. And little labor or manual labor is not needed for spray drying. Okay. But however, when we are talking about advantages, there's also disadvantages of spray dryer and what we call limitation or challenges. Okay. So materials that are rich in sugar and organic acid are difficult to spray dry because they tend to stick to the wall of the spray dryer. Okay. So you can see here the problem, the nature of the problem is stickiness. Once you dry, sometimes the product that has very, very high sugar, we call them low molecular weight, okay, low molecular weight sugar, they tend to stick at the wall of the spray dryer. So what we can do is the remedial action is that we can modify the spray dryer. We can adopt lower temperature, we can use dehumidified air, or maybe addition of high molecular carriers such as maltodextrin. We can use Arabic gum. We can use other carriers, okay, to help encapsulate the sugar so that it doesn't stick to the wall, right? So droplet size control during spray drying can also be challenging, leading to non-uniform drying, irregular morphology, and microstructure of the dried particles. We want a very good shape, circular shape for your powder in comparison to irregular shape, because irregular shape would mean it's not as easy to be compacted. Okay, so high temperature above 100 degrees C may result in losses of thermolabile. Thermolabile is actually a substance that can be deactivated by heat, okay, such as vitamin C, obviously, and other compounds, right? And one thing that is a bit of a disadvantage of spray drying, it is very energy intensive process. We use a lot of electricity, okay, to dry the product. And the thermal efficiency is very low, and of course the initial installation cost is quite high, and the equipment is bulky and very hard to clean. Okay, so the general process, if you could look here, okay, so the general process that are involved in spray drying a product is you need to concentrate your product, okay, meaning you need to lower the water content of your liquid first, okay, and then it will undergo an atomizer, all right, and there would be a droplet air contact, droplet drying and separation. Atomizing, droplet air contact, droplet drying and separation will happen within the spray dryer. Okay, where does it happen? Atomization happens here. Okay, if you can see the fine droplets here, okay, so this is where atomizing happens. And the droplet of air and your feedstock will happen around here, and the drying chamber or the drying process will happen around here. Okay, if you could see, I don't know if you could see my mouse, right? So it will happen in the drying chamber here. So this is where it will happen of droplet drying. Okay, the droplet air contact will happen around in this zone here, and atomizing happens here. Okay, and the separation will happen somewhere around here in the cyclone separator, right? So what we are separating is basically the powder form, and we are separating dust. Okay, so the HEPA that you see here is what we call the high efficiency okay, particulate air filter. So what it does is basically it filters the dust from the powder that from your product that you have spray dried. Okay, so concentration.
Dr. Nadiah, some students said that your voice is not clear.
Sorry?
Some students said that your voice is not clear enough.
Oh.
Can you please?
Okay, I will try to to increase my voice, maybe to increase the sound of my voice. Would that
Okay.
be okay? Because I'm using an earpod, it's inside my tudung. So
Oh ya,
I'm very sorry.
teman-teman mahasiswa sudah terdengar jelas.
Is it getting clearer atau masih lagi tidak berapa jelas?
Is it clearer, mahasiswa, student? Naufal tadi bagaimana? Sudah lebih jelas atau belum ya?
Can I hear your voice once again?
Okay. Can you hear me? Is it
I
clear?
can hear, I can hear, but it's still like not clear enough for me to hear your voice.
Not clear enough. Okay, I
Yeah,
will
not
try
clear
to
enough.
get out one of my earpods. Okay, is it better now?
Yeah, I think it's kind of better than
Okay, it's
before.
kind of better, yeah. Okay, I hope it will be better. All right. I will try to increase the level, the sound level of my voice. Maybe it's still early in the morning and I haven't had my coffee yet. Okay. All right. So one of the general process is the concentration. Okay. So basically, it is to increase the solid content of the liquid. Right. Is to reduce the amount of liquid that must be evaporated in the spray dryer. So you concentrate your feedstock. Okay. In this case, I need to write it down. Okay. If I'm talking about a feedstock, the feedstock is basically the inlet fluid. Okay. The inlet fluid or the fluid that you want to spray dry. Okay, so this, because sometimes you get a bit confused when talking about fluid. It could be the product, and it could also mean the air that we are dealing with, and also it could also mean the water, right? So that's why for the inlet fluid, I will call it feedstock. Okay, so the feedstock can either be in liquid form. Okay, it can either be in a slurry form. Slurry means semi-solid, right? So semi-solid means we have a very high percentage of water. Okay, so basically, concentration process is to reduce the amount of liquid that must be evaporated in the spray dryer, because we want to use as little energy as possible, so so that your spray dry do not use a lot of electricity. Okay, atomization is a process to create the powder form. Okay, so basically you want to lead to a dry product having the desired characteristics. And we usually use either nozzle or rotary atomizer to form a spray. Okay, and droplet air contact is basically the central element of a spray dryer, which is the spray dry chamber where the atomizer liquid is brought into contact with hot gas. Okay, atomizer liquid would mean feedstock liquid, right? Will be brought into contact with hot gas, usually air, in a vacuum. So we would result in the evaporation of 95% of water. And the way in which the spray makes contact with the air, the dryer influences the behavior of the droplet during the drying phase and have a direct bearing on the properties of the dried product. Okay, so basically what is it trying to say is that the droplet as air contact will dictate, will give you the result that you want. Okay, whether you want your powder to be in fine form, or maybe you want your powder to be in coarser form. Either you kamu mahukan powder ataupun kita panggil tepung itu dalam bentuk yang halus ataupun dalam bentuk yang kasar. Okay. So the droplet drying process is basically a moisture evaporation that takes place in two stages. Okay, so the first stages is where the saturated air temperature is equivalent to the drying air of the wet bulb. Okay, so that means there is sufficient moisture in the drop to replace the liquid evaporated at the surface. So the evaporation of the water will take place at a relatively constant rate. Okay, and the surface and evaporation then depends on the diffusion of the moisture through the shell, which is increasing in thickness. And the rate of evaporation will fall rapidly during the second phase. And finally, the separation, once you have got your powder product, okay, the primary separation is accomplished by particles simply falling to the bottom, okay, of the chamber, and small fraction of the particle remain entrained with the air and must be recovered in separation equipment. What does that mean is that when you have dried your product, some of the product may be within the air, the hot gas that is within the drying chamber. Okay? Some of your product may have gone through the cyclone separator, but some of it may still be here. Okay, so that is why we want your powder to be uniform size. Okay, because if it's not uniform, the smaller it is, sometimes your drying chamber may not consider it as a particle, and it will fall at the bottom and it will be collected as a dust. Right? Cyclones, back filters, and electrostatic precipitators may be used for the final separation stage, and we also have wet scrubber. So wet scrubber are often used to purify and cool the air so that it can be released to the atmosphere. Okay, so main component of spray dryer you would look at here, you would have the feed pump, the atomizer. Okay, the very important thing is the atomizer. You would have the filter. You would also have the drying chamber, the cyclone, where we want to separate our powder product, and we will also have another filter here. And they are available in different configurations and different layouts. Some are vertical, some are horizontal, and they can be classified based on atomizer type, the flow type, drying stage number, and air cycling type of the spray drying chamber. Right? So atomizer. Atomizer is often regarded as the heart of the spray drying process. Okay, this is where your drying kinetics, the quality of the resulting powder, and the energy efficiency of the process. Okay, the main goals of atomizer is basically to increase the surface to volume ratio to enable ultra rapid drying, to form tiny droplets, and to minimize losses of heat sensitive compound and particles with desired morphology and physicochemical properties. Okay, if you look at the figures here, we are not just talking about the drying chamber, but the most important thing is the nozzle part. The most important thing is the atomizer. So atomizer, the key parameters are the nozzle geometry. Okay, we also would like to see the spray solution composition. Does it have a lot of water? Does it have a lot of insoluble solid? Does it have a lot of sugar? Okay, and we also would like to see the atomization pressure on it. And the output of the atomizer, based on the three independent parameters, which dictates the output product that you will get in terms of the droplet size, in terms of solution flow rate, so on. Right? And droplet drying would help by the drying gas flow. Okay, so we would the drying gas here that is mixed with your feedstock would also dictate, okay, how what type of the product that you will get at the end. Okay, so it would dictate on the outlet temperature, the relative saturation, and also the solution flow rate. Okay, the first atomizer type. So this is a rotary atomizer. A rotary atomizer, basically it has a disc that looks something like this. So the disc would have very small holes, okay, at the side, where basically your fluid tube or your feedstock will come here, and the disc would be spinning at a very high speed, high rotation speed. So whatever the fluid that is on top of this disc, it will form a filament, a very small filament or very thin filament at the side of the disc, and eventually it will come down as a droplet. Okay, so this disc has to spin very, very high. Okay, so that is what it looks like, and the droplet size is is determined by the feed rate, the viscosity of your feedstock, and of course it would be dictated by the speed of your wheels here and the diameter of the wheel. Okay, so it uses energy of a high speed rotating wheel to divide the bulk liquid into droplets. And the feedstock is introduced at the center of the wheel, flows over to the surface or the side of the disc, and disintegrates into droplets when it leaves the wheel. So spray type can be adjusted from fine, medium to coarse, right? So dari halus, sederhana sampai ke kasar. Okay. So main advantages is the high feed rate, production of uniformly sized droplets, or to a very small droplet size. It is resistant to abrasion, not susceptible to clogging or fouling. Okay. Clogging is macam keadaan tersumbat. Okay. Can be operated longer times with good performance, do not need high pressure, and the particle size can be changed by changing the wheel speed. But the limitation is that you cannot use it for high viscosity feed. It's something that is semi-solid and cannot be used, right? So high energy consumption. It also has a very wide spray pattern and only available for vertical spray dryers, and has a very high cost and very expensive to maintain. So since it has a lot of limitations here, so they have innovated another two more atomizer types. Okay, so what you have here is what we call a pressure nozzle atomizer. Okay, we look at the right side of the figure here is the air-assisted pressure nozzle. If you look at the diagram, basically you would have the liquid will be coming in from the middle, and the air would come from the side of the nozzle, and it would merge here, and it will form what we call a liquid film, a very thin film. Okay, so pressure atomizers are also known as hydraulic atomizers or high pressure single fluid nozzle atomizers. What we have at the side here is another atomizer, is what we call a pneumatic atomizer. For the meantime, we will focus on this one only. Okay, what I'm showing here is just to compare these two, right? So the spray type for air-assisted pressure nozzle is coarse, right? So you will get a bit of kasar, okay? And the droplet size will depends on the feed rate, the viscosity of your feedstock, and of course, depending on the pressure of the atomizer itself. Okay, so pressure nozzles used in spray drying are called vortex because they contain features that cause the liquid passing through them to rotate, and the operating pressure range between 250 to 10,000 psi, very, very high pressure. Okay, so the main advantages is that we can produce powders with high bulk density with good flow characteristics. Okay, and it is relatively cheap, energy efficient, simple, and compact on the equipment itself, but it produces particles of greater size, coarser, freer flowing powders than rotary atomizers. But again, the limitation, it is not to be used with high viscosity feed. It may cause clogging and relatively low feed rate because it depends on the size of the outlet of the nozzle, and the capacity can be increased using multiple pressure nozzles. So instead of using maybe single one or just one nozzle, maybe you can use 2 or 3 or maybe more. At a high feed rate, the spray patterns tend to be less homogeneous and coarser, and their spray characteristics tend to vary over time as a result of abrasion. Okay. Another type of atomizer is what we call the pneumatic nozzle atomizer. Okay. We have two types here. One is what we call the external mixing. Another one is what we call the internal mixing. So the external mixing is what happens is the air will come out from the side, okay, from the side of the nozzle, for both of the nozzles, okay. But for the liquid channel, for the feedstock, okay, it will come through down here. For this one, it stops here, all right. And the mixing zones happens here. So the mixing between air and the feedstock happens here. So it will create a spray zone that looks something like this. But for the internal mixing, the mixing zone happens here. Okay, so the air and your feedstock mix here. So it will produces a spray zone that looks something like this. Okay, around here and here. This is because we want to minimize the clogging problem. Okay, to minimize clogging problem. Right? So this is also known as a twin fluid nozzle atomizers. It produces fine spray of fluid with aid of a compressed gas. Generally, we use air, which acts as the main energy source to generate the droplet. So droplet formation occurs as the liquid impacts the high velocity air jet, and cause droplets are formed first. Okay, you will get droplets yang a bit kasar mula-mula pada permulaannya, dan kemudian dia akan dapat droplets yang halus, very fine droplets. So spray type can vary from fine to medium and can be used on high viscosity fluid. Okay, so this one, the advantages of it, you can use it on a high viscosity fluid in comparison to the two atomizers we have spoken before. So the end product quality is closely related to the rheological properties of air and feed. So it's very, very, very fine. Okay. So the droplet size again, power masih sama dengan the pressure nozzle. Okay. So it depends on the feed rate, and the viscosity, and of course depending on the pressure. Okay. Main advantages is ability to handle viscous feed and to produce powder with very small particle sizes, relatively cheap, energy efficient, simple and compact, although compressed air adds to the operating cost. Okay, compressed air is a bit expensive. And the limitation is basically the relatively low feed rate and may cause clogging and also overspray. Overspray, what happens is an undesirable production of too small droplets or particles which easily get carried away to the atmosphere by the airflow instead of sedimenting at the bottom of the spray drying chamber. What happens is that it will get blown into the cyclone as a very small particle, and then it would get blown to the environment because it's very, very small. So what we don't want is basically an atmospheric pollution, okay, or air pollution. So this is another way of looking at the spray. Okay, so this is the external mix, and this is the internal mix. Okay, so another characteristics of spray drying is the flow types. What we have here is 3 flow types. So we have the co-current, the counter-current, and we also have the mixed mode. The type of contact between the feedstock and air is determined by the position of the atomizer to the air inlet. And most industrial spray dryers use co-current or mixed flow. Okay, if you look at the temperature characteristics, okay, for the air inlet, it comes in at 350 degrees. Okay, and as it goes further down, the temperature of the air would be decreasing. So it will be 100 degrees, 180 will be here, 170, 150, 130, until eventually will come out at 120 degrees. What happened is that because the energy was used to evaporate the powder, okay, to evaporate the liquid to form into powder. So for the feedstock, it will come in at 20 degrees C, and the temperature will get higher and higher until it goes down to the bottom to the product outlet, where it come out at about 95 to 100 degrees C. So that is the co-current. But for the counter-current, if you look at the feed will come out from the top, okay? But the air inlet will come out from the bottom. So your air inlet will come in at 350 degrees C, and it will go further up. It will come out at 125 degrees C as it evaporates the liquid from the feedstock. So your feedstock will come in at 20 degrees C, and the temperature will increase to a bit higher than from the co-current one. Okay, because why? Because interacts with the air inlet at about 350 degrees C. Okay, so we do not recommend for a heat sensitive product to be used with the counter current. Okay. For the mixed mode, what happens is you would have an air inlet that will come in from the top. Okay, so at about higher temperature than the co-current and the counter current is about 450 degrees C. And then the temperature will go down a bit at 400 degrees C and goes to the bottom. The atomizer or your feedstock will come in from the bottom instead. So what happened is you would have spray of feedstock and air, and then the air would push your powder form to go to the bottom. So the product outlet would be of a temperature of 95 to 100 degrees C. Okay, and the air outlet would be 135 degrees C. So what happens here will have is basically a mixed mode flow, right? So you would have your air coming in from the top, and you would have your product coming in from the bottom, right? So the the co-current is actually a preferred design for heat-sensitive products such as dairy, eggs, or fruit juices because the hottest drying air contacts the droplets when the moisture content is at the highest. So the spray evaporation is very rapid. Temperature of the drying air is quickly reduced by the vaporization of water. So as you could see previously, the air that will come in from the top will be a temperature a bit high, and as it goes to the bottom, it will be decreased, right? The product does not suffer from any heat degradation because the droplet temperature is low during most of the evaporation time, and once the moisture content reaches the target level of your needs, the temperature of the particle does not increase greatly because the outlet air is now much cooler, okay, between 50 to 80 degrees C. For the counter current spray, okay, the spray and the air are introduced at the opposite end. Okay, so your product come in from the top. This is your atomizer. Your hot air will come in from the bottom. Okay? Atomizer position at the top and air entering at the bottom. More rapid evaporation and higher energy efficiency than the co-current. But it is not suitable for heat sensitive products because because the exit temperature of the product when the moisture content is the lowest is close to the inlet air temperature and higher than the outlet air temperature. So usually we use counter current for soap and detergent making, right? So for the mixed flow spray dryer, it's a combination of both soap and counter current. So air will enter from the top and the atomizer will be placed at the bottom. Like the counter current design, a mixed flow dryer exposes the driest particles to the hottest air. And this design, again, is not to be used with heat-sensitive products. And they can also be used when you want a coarser, free-flowing powder. Another parameters that you need to look at when you are designing a spray dryer is the air cycle type. There are two types, okay? So one is what we call the open cycle dryer. Okay, so air is drawn from the atmosphere, it's being heated, and it is being conveyed through the chamber and then exhausted through the atmosphere. So basically, you would get the air from the ambient, it will be heated, and then it will go to the drying chamber, and then it will be disseminated to the environment. And this is the most commonly used. Another one is what we call the closed cycle spray dryer. Okay, so closed cycle usually we do not use air. We use it more when we are dealing with a nitrogen. Okay, so closed cycle units are dryers of choice when your feedstock consists of solid mixed with flammable organic solvent, and complete recovery of solvent is required and the products are toxic, and we do not want any pollution to the vapor, particulate emissions, or any odor. So another thing that we would like to eliminate is the explosion risk. So that's why this is a closed cycle spray dryer. And the powder will degrade by oxidation used during drying. So that's why closed cycle we usually use for pharmaceutical product or anything that is a bit toxic. Right? And we have another one, we call it semi-closed. This one is a bit of a mixture between the open and the closed one. This is a design, okay, a cross between open and closed dryers, and it is not gas tight. The difference is that if you look at this closely, this one is a closed spray drying system. This one is a semi-closed. The difference is you have an exhaust lid at the scrubber or at the condenser here. So what happens is that you would have what we call not a gas tight process. Okay, so basically you will have an exhaust fan that you can flow out whatever the byproduct that you do not want. Okay, another thing that is very important for you to acknowledge when you are dealing with spray dryer is the drying stage number. We have two types, the single stage and the two stage. So the single stage is the most widely used design, okay, because the moisture content is reduced to approximately about 2 to 5%, which is the target moisture content that you would want for your powder. And it only happens in one pass, meaning at only one time of flow. So meaning you would have your feedstock going on here, and then directly you will get a powder of a moisture content about 2 to 5% of moisture content. Okay, so it operates at a temperature about 150 to 220, and the outlet temperature is about 95 degrees or higher if the lower moisture content is required. But for a two-stage dryer, what happens to your powder? It will go towards a two-stage drying process. The first stage would be the spray dryer, where the spray dryer would produce a powder of about 5 to 10% of moisture content. And then it will go to the second stage where you would have a fluidized bed dryer or a vibrating bed dryer. You could see here at the very bottom, you would have a vibrating fluid bed. So this one would further dry your product to your to the moisture content that you would need for your powder. And it allows the use of lower temperature for your spray dryer. So you would not use a temperature that is as high as the single stage dryer, right? And it is a good choice for products that are particularly heat sensitive. So applications of spray dryer, basically milk products, okay? By volume of product dried, the dairy industry is by far the largest user of spray dryers for food processing. And milk is always concentrated in a falling film evaporators to a solid content of 45 to 55% before spray drying, because the cost of removing water in an evaporator is about 1/10 of the cost of removing in a spray dryer. So basically what you are dealing with when you want to dry your milk product is a two-stage spray dryer. So what the first stage is the concentrator, or we call the falling film evaporators, and then the second stage is using a spray dryer. So both rotary and pressure nozzle atomizers have been used, but in recent years, rotary atomizers have been replaced almost entirely by nozzles. So now we are using nozzles more in comparison to the rotary atomizers. And spray dried milk products are really soft and dry mix when utilized. So it's easy for you to reconstitute, or you want to produce other milk products if you were to use milk powder that has been spray dried. Okay. So other milk products that have been that have used spray drying methods are caseinates. Okay. You would have coffee whitener. You would have also cream, baby food, ice cream mix, whey permit, cheese, butter, okay, skim milk, whey, buttermilk, cocoa milk with sugar. A lot of products that have been used with spray drying. So other applications, egg products, eggs are broken, separated unless processed whole and pasteurized. So they are pasteurized first, and then they would use a spray dryer, especially using a cool current spray dryer, using either rotary or nozzle atomizer. So the product you have is either egg white powder alone, or the egg yolk powder alone, or the whole egg powder, right? For domestic use, okay, we don't usually see egg powders in the market. These are usually used for bakery industry. Okay, so they would use eggs because sometimes using a whole egg where you have to crack your eggs and everything, it would cause a slight risk to contamination. So they would like to eliminate this. Um, so they would use an egg powder instead of fresh eggs. Okay, so instant coffee powders. Prior to spray drying, the coffee beans are cleaned, blended, roasted, and granulated, and the ground beans are then put through an extraction process, and that produces a liquor that is subsequently spray dried. So all those Nescafe, Cafe that you have in your house, the instant coffee types, are basically spray dried. Okay, and the drying is done using co-current dryers using pressure nozzle atomizers. Basically, because you can get a coarser type of, of coffee powders, right? Other usage of spray dryers is to produce edible plant protein. Okay, it can be extracted from soya bean milk. Okay, so from isolated, you can get about 90%. Concentrated, you can get about 60 70%. And you can also extract plant protein from peanuts, sunflower seeds, leaves, forage crops, herbal, something like that, and potatoes. Okay, so other than plant proteins, you can also extract milk, you can extract fat flour, cake mixes, artichokes, cereals, protein hydrolysate, a lot more. And yeast products, okay, so you can produce brewer yeast, powder yeast, single cell protein, and yeast extracts and yeast hydrolysate. Okay, the definitions of all these yeasts are provided below. Okay, you can read about it. So other applications are fruit and vegetable products. Okay, you have a fruit pulp, a juice and paste that can be spray dried. But due to the sugar content, remember we have talked about the sugar content. When the sugar contents of your feedstock are high, the tendency of your product or your powder to stick at the wall of the drying chamber is very high. So most food products would require the addition of fillers, or what we call encapsulation agents. Okay, carriers or encapsulation agents. So what it does is basically you would have your food products or your food powders be encapsulated by the carrier or by an agent. It's very, very small. You cannot see it with your eyes. So basically, we can use either maltodextrin, we can use gum arabic. Okay, these are some of the micro encapsulation agents that are available. Okay, so your food powders would be inside. It's going to be very, very small. You cannot see it actually. Okay, so in order for it, when you have this encapsulation agent, what happens is that it does not stick to the wall of the drying chamber. So you can basically get your powder in a very good form, uniform size and everything. It can be separated and it can be collected, right? Tomato is the most extensively dried fruit. Okay. In Malaysia, I have not seen any tomato powder, but I have seen orange powder, yes, in bakery supply shops. Okay. I have seen other fruits like mango, but I have not seen tomato. Maybe it's not being used here. Okay. So apricots, asparagus, bananas, beans, beetroot, carrot, citrus, mango, onion, peach, and other soft fruits can be used and can be spray dried. The carbohydrates and similar products such as baking compounds, corn seed liquor, corn syrup, glucose, gum arabic, maize gluten, pectin, sorbitol, starches, sugar, gelatin mixtures, sweeteners, total sugar, wheat flour, and wheat gluten are all can be spray dried. Okay, so recent advances, one of them is vacuum spray dry. So basically you would have a spray drying method and you would have a freeze drying first. This is a freeze drying vessel, FD vessel, and this would be your product, okay, powder product, and this would be the atomizer here, okay. So this would be your spray dryer, okay. So this is a freeze vacuum spray dry. Drying is performed at low temperature under vacuum. So it is an advantage to you to produce heat sensitive material, and the product that is produced is stable under oxidation condition, meaning if you were to put it at environment with high oxygen, it doesn't change color or anything like that. And it is a suitable technique for encapsulation of ingredients that are unstable in aqueous media. And however, the limitation is the long processing time, high energy consumption, because freeze drying is not cheap. It's very expensive operation, and poor ingredient protection due to porous coating of the encapsulation itself. Okay. Other recent advances are nano spray dryers. Okay, so it allows to produce particles in the range of 300 nanometers to 5 micrometers with a narrow size distribution. Very high yield up to 90%, minimal sample amount of as minimal as 1 milliliter, and low operating cost, energy efficient technology, fast processing, high encapsulation efficiency. You can control the particle size, the shape and morphology that you want, and the process simplicity and operational ease. So basically, it looks something like this, where you would have this is the nano spray here. It uses the corona discharge. Okay, so the corona discharge is here. So basically, you would atomize your feedstock and your air around here, and the fluid will go down here. What will happen is fluid would be at the top of this buffers or levers here, where it has a small hole, and the droplets will be pulled downwards, and the charged particles would then get a very, very small size, very fine size. Okay, and ultrasonic spray dryer, basically it introduces ultrasonic at the probe, at the atomizer. Okay, if you look at this here, I would like you for you to focus at this here. So this is an ultrasonic nozzle. What does it look like? Is basically something like this. Okay, you see it from the side. So this is the liquid feedstock channel. It will go down with the mixing gas, but the ultrasonic would be introduced here. So you will get an agitated or vibration of your liquid at a very high energy to induce droplet formation. And it will result in very small droplets with uniform size distribution. And you would have shorter drying times, suitable for heat sensitive material, less susceptible to clogging, limited to low viscosity and low flow rates, and low velocity spray allows the drying chamber to be designed with small dimension and can be operated at low energy levels. Another advances of spray drying is dehumidified spray dryer. Okay, so low moisture content and relative humidity of the air improve the driving force for drying even at lower temperature. So dehumidified air is produced by an air dehumidifying system connected to the drying chamber. So this is the air humidifying system. So whatever the air that you get from the environment will go through the air dehumidifying. It will suck up all the moisture from the air. So the air that would be introduced to your feedstock, it does not have any moisture. Okay, so you can use a low temperature to dry your feedstock into powder. This would be very beneficial for your product that has very high sugar. So any product, any feedstock that has high sugar can be used with this dehumidifier. So because what happens is that it does not stick to the wall of your drying chamber. And the product has lower residual moisture content, higher bulk density, and particle with smooth surface. Okay, so in summary, basically before you start drying using spray drying, you need to know the moisture concentration, the rheological property that you would want, okay, and the heat tolerance of your product. Okay, you also would need to know whatever the bioactivity of your product that you would like to retain. And during the drying process, what you can do is you can control the drying conditions in terms of the inlet temperature, the outlet temperature, the feeding rate, evaporation efficiency, the airflow, drying aids, and the carriers. So you can choose the nozzle that you would like to use. You can choose the airflow type, and you can also choose your drying stage number. And after that, you can get a powder of your desire. Okay, the particle size distribution in terms of the morphology, and you can also check on the glass transition. So that is the summary for the spray drying technique. Ibu, do you think we can give them a 5 minutes break? Okay. I think Ibu Asri cannot hear us, maybe. Can? Oh, okay. Okay, can we stop here for 5 minutes break? You guys can have a drink or something, okay? And we move to the drum drying process.
Okay, Dr. Nadiah.
All right, 5 minutes. Thank you.
Thank you.
Okay, class. May we start? May we resume our class? Boleh ya, Bu?
Silakan Bu Nadiah kalau mau
Alright.
dilanjutkan kembali.
Terima kasih. Okay. So the second topic of the day is drum drying. Okay. So what you are seeing here at the left side is the twin drum drying. Okay, we will discuss a bit in a bit what is drum drying is. So drum dryer was invented by this guy here, John Augustus Just. Okay, so he's an American citizen, and he intended to again dry milk because at that time milk is the cheapest protein that are available for their citizens. So that is why milk is a very huge focus, has a very huge focus on the invention of the new technology. So he patented the drum drying process of milk products into powder in November 1902. Okay, so it has been quite some time ago. This drum drying process, and it still is still being used throughout now. All right, so if you look at the future forecast, I'm not looking into the milk. Okay, I'm looking into the potato flakes market. So we are looking at the 10-year market that is about 2019 until 2029, and the growth is about 7%. Okay, it is still not as high as spray drying, but drum dryer is still being used extensively because of its cheap. It is cheap and it is easier to use. Okay, so the principle of it is basically you would have a heated hollow metal drum. So the metal drum is hollow. Okay, it's not solid, right? And it rotates on its longitudinal axis. It's partially dipped in the solution to be dried. So basically, the solution is your feedstock that you want to dry into dry form. Okay, and the solution usually either slurry or viscous in nature are spread mechanically as a thin film on the rotating surface of a steam heated dryer. So this dryer is hollow, and you would have steam flowing through the hollow metal drum, and you would have your slurry at the bottom, and it would move clockwise and in a liquid form, and as it moves further it would be dried. So once it goes to the right side here where it meets the doctor's knife, what you get is a powder form, so it looks something like that. Okay, so the film is then rapidly dried conductively by high heat that is generated within the drum, and the dried film is then scraped with the help of a knife while the drum is rotating. So the process is also known as a roller drying. So drum drying requires less space and is more economical than spray dryer for small volume. So that's why drum dryer is still being used extensively nowadays. And the drum dryer is very flexible in nature, and its operation depends on the pressure of the steam within the drum, okay, the speed of the drum rotation, width of the applicator, and the ratio of drum speed rotation. And all these parameters can be controlled or regulated independently without any dependency on each other. Okay, remember before this we were talking about spray drying, the droplet size would highly depend on the feed rate, the viscosity, the nozzle pressure. This one it does not depend on anything. Okay, so basically you get your powder form. It only depends on the pressure, but it's not depending on the speed, on ratio. Everything is depending on its own. Sorry. Okay, so the system description is you would have a diameter of a typical drum that is about 0.5 to 6 meter, and the length from 1 to 6 meters. And the moist material is uniformly applied in a thin layer between 0.5 to 2 millimeter onto the outer drum surface. So you will get something look like that. Okay, and then it will go into a hopper. Usually a hopper would have a grinder, so a grinder would produce your powder form. Okay, the ratio of steam consumption to water is between 1.2 to 1.6, right? And the steam pressure in drum is between 29 to 115 psi. So very small pressure in comparison to the spray dryer. And rotation speed can vary between 2 to 30 RPM, and the ratio of drum rotation speed is between 1 to 5. Okay, so one of the examples of your product is here. This is, I don't know if you guys are familiar, this is Nestle Nestum. Okay, that is usually, you dissolve in milk and you drink it early in the morning. So basically, they use this drum dryer process to produce Nestum. Okay, and also other baby food products, like those small rice Nestum, they are also using drum dryer. Okay, in operation, steam can be at a temperature of about 200 degrees C. So the steam within the hollow drum dryer just now can be at a temperature of about 200 degrees C to heat the inner surface of the drum. Okay, so you can see it is higher than the boiling temperature of water. So the drum surface temperature can be as high as 130 or even higher than that. Okay, and the energy consumption in the drum dryer may range between 1.1 kilogram steam per kilogram of evaporated water to 1.6. So it corresponds to an energy efficiency of about 60 to 90%. And under ideal conditions, the maximum evaporation capacity of a drum dryer is about 80 kilograms of water per hour per meter square. So advantages, drying time is very minimal, between 6 to 15 seconds. And so heat sensitive material can be dried. The product has good porosity and good rehydration due to boiling evaporation. And it can dry very viscous foods such as paste, gelatinized or cooked starch, which cannot be dried with other methods. And it has a very high energy efficiency, easy to operate and maintain, compact and use less space, and product obtained is completely dry. But the disadvantages is that some product may not form a good film on the drum surface and not suitable for drum drying. And some product, especially those with high sugar content, may not be easily scraped off from the drum. And there is a relatively low throughput compared to spray drying. And because of the precision machining that is required, there is a high cost of changing the drum surface. The drum surface has to be changed depending on how heavy the usage are. Okay, there is a possible scorching of the product to impart cooked flavor and off color due to direct contact with the high temperature drum surface. When the temperature is quite high, sometimes your product can be cooked, okay, to a certain point where we don't want it to be. Okay, and it is not possible to process salty or other corrosive material due to the potential pitting of the drum surface. What do you know what pitting is? Pitting would be a bit like when you have acne on your face. Okay, so we don't want that. Okay, we don't want any of the pitting on the surface of the drum, because then you would create an uneven thickness of the film. So classification of drum dryer can be classified in two stages, okay, operating pressure and the number of drums. And feeding methods also can depend on whatever the stages that you have chosen. And material of construction can depend on the alloy, can be made from stainless steel, chrome, or nickel plated steel, right? Operating pressures, there's only two, atmospheric and vacuum type. So the number of drum can be single, double, or twin. Okay, so there's a difference between the double and the twin. We will discuss it later. And the feeding methods can come either from nip, flash, spray, dip, or roller feed. And it can be a combination of either of them. Okay, so operating pressure, we have only two, right? We have the atmospheric drum dryer and the vacuum drum dryer. Obviously, when talking about vacuum drum dryer, it needs to be in a containable vessel. Okay, so it has to be in a closed vessel. drum dryer, it, it will be an open vessel, right? So air and contact drying under atmospheric pressure. In air and contact drying, heat is transferred to the foodstuff or your feedstock either from heated air or from heated surfaces. Okay, so the water vapor is removed with the air. But for the vacuum drum dryer is done taken from the fact that evaporation of water occurs more readily at lower pressure than the higher one. So heat transfer in vacuum drying is generally by conduction and sometimes can be done using radiation. Okay, so types of drum drying. We have a single drum. So single drum consists of, again, hollow metal cylinder mounted on a horizontal axis. So this one is from the side, from the side, yes. If you look from another side of it, it would look something like this. So you would have a metal drum that is hollow. Okay. Mounted on horizontal axis and mechanically rotated with a variable speed control. So you can adjust the speed, the rotation of your drum. And the drum is heated by steam, hot water, or other heating medium condensing on its inside surface. And the drying effect being obtained by the transfer of heat from the inside of the drum to the metallic wall to the film of material or your feedstock over its external surface. So it will come from the inside. It's either come from the hot water, it can come from steam or other medium, or maybe you can just heat up your vessel. You can also do that, right? And then it goes straight away to your feedstock that you would like to dry. Important aspect to consider when using a single drum dryer is the uniform thickness of the film. Okay, so it needs to be uniform. So if you are thinking about 1 millimeter, so it needs to be 1 millimeter at all times. And the speed of rotation. So the higher the speed, okay, sometimes may produce a product that is not dry enough, right? So you need to control the speed of rotating and of course the heating temperature. So higher heating temperature, higher drying time. And all of these factors affect the drying rate of the dryer, and consequently several types of drum dryer have been developed. So besides a single, we also looking at a double drum dryer. So double drum dryer looks something like this. So if the drum may be rotating, okay, coming in, this one clockwise and this one is counterclockwise. Okay, the drum dryer consists of two cylinders equal diameter rotating very close together in opposite directions, and the material to be dried is fed through the wedge-shaped space between the drum using a distribution pipe. So this is a distribution pipe where it gives out the feedstock. And heat is transferred from the hot drum surfaces to the wet material, to your feedstock. And the rotation of the cylinders causes the material to pool in the pool to pass through the narrow space between them. So this is the feedstock, dividing the material into two films, which after drying are removed in the form of thin sheets by scraper blade spanning the whole width of the drum. So this is your knife. Your knife will be here. So whatever your product will be here, and then it will move to here, and then it will meet the knife. Okay, the most significant factors in efficiency of the double drum dryer are steam pressure, the drum rotating speed, again the level of pull between the drums. Okay, it cannot be too high. It will create an ununiform film thickness. Gap between the drums, it cannot be, the drum has to meet each other. Okay, it cannot have a gap. And the conditions of the feed material, including the concentration, the physical characteristic, and temperature at which the material reaches the drum surface. And this drum dryer, it can handle a wider range of products and usually offer better economy, more efficiency, higher production, and fewer operating labor requirement than other equipment. Okay, so types of drum, another types of drum drying is twin drum drying. Okay, what's the difference is that it still has two drums, okay, but they either rotate away from each other okay, at the top or has two different feed pipes. So previously we only have one feed pipe. This one has two feed pipes. Okay, and the single and double drum dryers are largely used for drying fruits and vegetables, while twin drum dryers are particularly adapted for drying materials such as solution of inorganic salts, okay, and for drying materials yielding dusty products. Okay, anything that has a very dusty product, then we can use twin drying. Okay, and here's another. They call it doctor's blade or doctor's knife. It's very very sharp. Okay, so the feeding methods. Feeding methods have 5 types. So one of it is a roller feed. Okay, so you would roll about where your feet will come from the middle or maybe come from the side. Okay, this is a nip feed. Nip feed would come in from the pool in the middle. Okay, remember you look at the rotating drums, it touches each other. This one, it doesn't touch each other. Okay, the tip feed, it doesn't again touch each other, but the hollow metal would be dipped into your feedstock solution. Okay, for the spray feed, the feedstock solution would be sprayed onto your metal drum, and for the splash, again, it's the same as the spray. It will be splashed onto your metal drum. That is 5 types. Okay, so for feeding methods, if you look at this here, this one is a single drum dryer with applicator roller feed. So basically, you would have your feet coming in from here. Your drums will be moving counterclockwise. Okay, and the applicator roller is to make sure that you will get a uniform thickness of your film. Okay, and then it will move from the left to the right, and then it will meet the doctor's blade where it will be accumulated into the screw conveyor. Then it will go into what we call a crusher or the grinder. Okay, so then you will get a powder form. Single drum dryer with deep feed. Okay, so your metal hollow drum would be partially dipped or submerged into your feedstock liquid. And you will move from the left to the right, and then your doctor's blade will be at the bottom here. For the dryer with deep roller feed, this one is basically you would have 2 methods combined together. You would have your dip, but you would also have your roller. So your roller is to make sure your roller is that is being submerged into your feedstock liquid, and it would make sure that you will have a uniform thickness of your film. Okay, and then it will move from the left to the right, and then it will meet the doctor's blade. For a single drum dryer with splasher or sprayer feed, your splasher or your sprayer would be the one that is being submerged into the feedstock liquid, right? This one is a double drum dryer with mid feed. Okay, the feed will come from the middle. The typical applications for drying of yeast, milk products, detergents, and dye stuff materials. Okay, for twin drum dryer with applicator roller feed, this one has 2 feet, okay, double feet. This one is for a cereal-based breakfast food, such as Nestum just now, baby food products, pre-gelatinized starches, fruit pulp and paste, and potato flakes. Potato flakes are the one that is being used to make mashed potato, instant mashed potato. Okay, so this one is twin drum dryer with deep feed. Okay, both of the drum is being submerged, okay, partially in the feedstock liquid. It is for typical application for drying of cereals and spent yeast. Spent yeast are basically byproducts that came from beer or wine production for over many years that have been used as a feed additive for livestock. Okay, so it's been used to make into animal feedstock. Right. Twin drum dryer with splasher or sprayer feed would be something like this. Typical application is for animal-based glue, pesticide, or gelatin. Okay. So features of drum dryer is basically a uniform drying across the material due to uniform application and maintaining uniform pressure across the drum. And it is suitable for highly viscous, pasty, slurry type of materials, and for heat sensitive material because of its shorter drying time. It is highly adjustable. The component of the drum dryer such as pressure, rotation speed, applicator width, and other can be adjusted and it offers a very high thermal efficiency compared to other drying system, as the drying takes place due to transfer of heat from within drum to outside drum. It is easy to clean and to maintain in comparison to the spray dryer, and it has a wide range of size and heat transfer to handle wide range of materials, and it can be operated in a continuous drying mode. Okay, so application of drum dryer are such. Okay, so you would have cereal-based baby food, milk for milk powders, skim milk, tomato puree, broth, yeast, coffee powders, okay, and such. And also for industrial usage, you can produce a calcium carbonate, okay, salt, animal glue, soya residue such as okara. You can also produce other antibiotics, pesticide, insecticide, and so on. Okay, that is it for my lecture for today. Can we take about 10 minutes to do a simple quiz for the students?
Yes, sir.
All right.
Yeah.
Okay, so you can scan the QR code at
The
the
QR
bottom
code.
here.
Okay.
Yeah, or maybe I can copy paste the link at the chat box.
Silakan semua mahasiswa untuk mengakses ini kuis dari Bu Dr. Nadiah. Yang punya aplikasi QR code boleh ini ya, langsung di scan langsung ya. Ini saya coba. Oh, sudah masuk. Berhasil, Bu. Ini bisa masuk.
Boleh masuk?
Iya, sudah bisa masuk.
Alright. Okay. So this is link kalau siapa-siapa tak boleh masuk ya. Stop my sharing. Lepas ini kita buat question Q&A session ya. Ibu kalau ada soalan daripada mahasiswa.
Iya, ada 20 question. Soalnya ada jumlahnya berapa, Bu? How much the
15.
15?
15
Oke.
questions. Ya.
Ya. Dr. Nadiah.
Ya,
Berapa lama lagi ini untuk kuisnya? Sudah.
baru ada 3 orang sahaja.
Ya, saya juga mengumpulkan, tapi banyak salah. Kurang teliti. Ya.
Is it my lecture yang tidak efektif?
Nah, I think because apa ya? eh, kami belum mengetahui secara detail apa tipikal karena banyak jenisnya gitu. Jadi terkecoh
Betul.
dengan
Faham.
pilihannya.
Sometimes it gets a bit confusing between one drying method to another drying method.
Ya,
Yeah, that's it. Um, saya pun kalau jika tidak buat slide ni pun tak begitu fokus kepada drying method tertentu. Jadi sambil mengajar kita belajar juga kan. So yeah, it's a good thing juga saya dapat mengajar subjek ni.
oke, iya.
Okay, baru 4 orang. They can still submit to the quiz. I don't mind. I will still accept the form, and you will directly get the results later. But can we open for Q&A session if there is? Kalau ada soalannya dari mahasiswa.
Silahkan, if you have any question, you can type in the chat box or you may raise hand and ask directly to Dr. Nadiah. Is there any student? Naufal, barangkali? Naufal, do you have any question to Dr. Nadiah?
You can ask in bahasa. Maybe Ibu Asri can translate in English if I don't understand. Yeah.
I'm sorry, I don't really have any questions for now.
Okay. It's okay. We still have another 2 weeks. Do they know that they have to do a presentation on the 3rd week?
Yeah.
Okay.
Yeah.
All right. Okay, that's good. Okay. So we have another session next week on superheated steam drying. Okay. So I will, if you guys don't have any question, I guess we will see each other next week. Okay.
Yeah.
Right.
Okay. If the
Terima
student
kasih
didn't,
mahasiswa semua.
yeah, Dr. Nadiah, if the student they don't have any question, maybe I will ask a little bit about the best method for making dried plant extract. I think is it suitable to use spray dryer or drum dryer to produce dried plant extract?
I guess it depends on the capacity or depends on the quantity that you would like to produce. So if you like to produce a small amount, then maybe spray drying would be more economical. But want to make into a huge batch, I guess use drum drying. It would be better. Yeah.
Actually, we have research about Rosella tea.
Okay,
Then
that's interesting.
we want to make instant drink, but
Okay.
we don't have a spray dryer here.
Oh, okay.
So we use a vacuum dryer now
Okay.
in our lab, but the product is not good enough for
I see.
instant drying. So
Okay.
I think the material which contact to the high pressure, yeah, especially in spray dryer or maybe another dryer, it will I mean it will change or degrade the material. Especially for Rosella, it's also thermolabile material. So some antioxidant degradation and the color, especially the color, is very different. Do you have any experience about drying some product in Malaysia?
to be very honest, at the moment, I'm currently producing coconut water vinegar. So from the coconut water, tender or mature coconut water, we have available here. So we collect them and we try to ferment them to produce something like apple cider vinegar, some sort. And then we try to freeze dry them. Spray dry. But we haven't seen the result yet. But I will share with you soon if I have it. But I think I would like to invite you on that research together if you are interested. And maybe we can just we also have Roselle here. Maybe you can share your methods of producing the liquid for Roselle tea, and then maybe I can try to spray dry.
Okay, thank you. Thank you for the
Using the equipment that we have. We have a very small equipment. It's not big, but I think it's good to see what's the effect of the Roselle tea in terms of the antioxidant, the color especially, right? Because we don't want to see any oxidization or it turning brown or something. But that is very interesting. But we
Yeah.
need to find out whether it needs carrier or not. Maybe it would need maltodextrin.
maltodextrin and other glass transformer such as gum Arab, rabbit
Yeah.
gum. Yeah.
Yes.
We also try to do foam drying
Okay.
using white egg foam.
Yes. Format drying.
Foam drying.
Busa.
Ya, busa dari putih telur. Yeah.
Okay, so but how is it? Is it does the color change so much? I mean, colornya berubah banyak tak?
Iya, berubah sekali, Bu. Jadi the color become
Very dark.
yeah, I think there is some oxidation or fermentation during the drying process.
So it's a shame because Rosa has a lot of anthocyanin that is very good for our body. But have you tried drinking it after the busa, the format drying? Have you tried apa dilute in water and drinking it? Does the taste feel the same ataupun rasanya sudah berubah?
Kami belum menambahkan gula gitu. Jadi ketika we dilute in the water, we still see some solid material and of course it doesn't have any taste. So we are confused how to add some sugar in the instant drink because some of my colleagues here they say to add glass transformer instead of using any dryer. So they modified glass transformer and using some material. I think I didn't have any experience about glass transformer and other.
But I think using maltodextrin would help, rasanya. Maltodextrin a bit manis kan?
Yeah, maltodextrin with specific dextrose equivalent, or we can use any maltodextrin. We have many from corn and other from.
I think we have to figure out which maltodextrin we would like to use. Yes, that's very interesting actually. I haven't tried it. I did a bit of research on Roselle tea using an ultrasonic to extract as much anthocyanin as possible. But beyond that, I did not do any further research. But it's very good to do that spray drying method, just to try it, and we can compare in terms of the anthocyanin content, availability of it after some time after the shelf life. Yeah, that would be good. Ibu, later we can maybe perhaps discuss more on that.
Yeah.
Okay.
Yeah. Well, students, do you have any question for drum dryer, perhaps? If for spray dryer, I think students, you have to understand more about the engineering design, Dr. Nadiah, because I remember when I was in in bachelor degree, I calculate about heat and mass balance in spray dryer and also in
Dryer.
sun dryer. Yeah.
Yes.
And also about how to predict the drying time of spray dryer and also drum dryer. So
Yeah, that would be good.
then you can learn more in maybe in health mansing, introduction to food engineering, or other books, or you can download in YouTube about the calculation, the engineering calculation.
Doing calculation.
If Dr. Nadia give explanation about comprehensive uh, mechanism and other also application about spray and drum dryer. But for the calculation, you have to study more
Yeah.
because maybe di akhir perkuliahan for sarjana, here we have uh, perancangan or design of process, Dr. Nadia. So they have to calculate. They will select drying process or maybe storage or maybe extraction. They have to design optimal process
Yeah.
in order to graduate from
That would
agricultural
be
engineering.
so that when they graduated, they can eventually, design all this process themselves.
Yeah.
Yeah. Okay.
Okay. I think I have one last question about drum drying, Dr. Nadia. For the process, I think mostly about conduction heat transfer ya in drum dryer. But
Maaf, Ibu, apa dia?
ya, untuk ini apa the mechanism of drum dryer?
Yes.
Yeah, I think it mostly conduct by conduction heat transfer.
Yes, I
But
agree. I agree.
I still have no idea about how the dried material is they can turn down. So I think I with some the doctor knife or blade, yeah, scraper for I mean to remove the dried material in the surface of the drum.
Mhm.
So they will still rotate, but how to apa ya to let down the dried material. So I think I see or maybe knife or
Yes, they use a knife
the function of knife or doctor blade
to
or
make
something.
product.
Yeah.
Yeah. It looks something like this. Usually they would have a knife, but this
Yeah.
one, it has already been scraped from the drum, so that's why it come out as a thin layer, and then it will go to a screw conveyor, and it will go directly to a crusher or a grinder.
So the
it uses
process
a
will
knife.
be initial hitting the drum first. We have to do initial hitting for drum,
Initial heating of the drum, yes.
and then the
Either
second
the drum
product.
directly, or
Oh.
maybe you would use steam or hot air,
Hmm.
because the drum has small holes on top of it.
Oh.
If you look at this here, it looks very smooth, right? But sometimes they have a perforated holes. They have very, very small holes that they can use. In this case, I would assume that what it's using is actually is conduction. Basically, they hit the drum directly. But sometimes if you were to see any holes on top of this, that means the water vapor or maybe the steam will come out from here. But the holes have to be very, very small so that the liquid, whatever that you have on top of this, would not flow back to into the drum.
So during drum drying, it will be also constant rate period and also falling rate period. Yeah.
Definitely, it needs to be a constant rate. Otherwise, you will get an uneven drying.
So mostly it is for flake product. Yeah. For potato flakes and maybe
Potato flakes
nestum.
or nestum, yeah,
Nestum, yeah.
for baby food, or maybe some sort of detergent that you see the ones that have flakes on them instead of a powder form, something like that.
So we can also make some product in the form of sheet product. I think like some thin film. For
Yeah,
example, crispy mushroom sheet.
yeah, sure.
Yeah, using
True, we
this.
can use this.
Oh, yeah, okay. But I think for the infestation and for the cost for to using this type of drying will be quite expensive, I think.
Yeah, I think the capital cost is a bit expensive because it's quite a huge product. It's
Yeah.
quite big, up to 6 meter long. But the operating cost I think is quite low.
Hmm.
Maybe just uses this heat to heat up the product. But other than that, I don't think it's as expensive as spray dryer. The issue with spray dryer, even the one that we have in our lab, is that it's prone to clogging because the product will go into the nozzle, and then sometimes what happens is it dries at the nozzle tip. So then the product would clog at the nozzle. So you would have to do maintenance quite regularly. So you would have to send to the supplier to wash it off because we cannot clean it ourselves sometimes because the nozzle is quite small. So we don't have any equipment to clean it very well. So that's why that's the issue with our, maybe because it's just a small scale and the product that we have used is a lot. So it is prone to clogging. So drum dryer, it doesn't have any problem with clogging, but it needs quite a bigger space in comparison to the spray dryer.
Okay, so in the in my opinion, so the density of the product will be the most important in spray dryer. The density of or yeah, the solid material of the density will be important things in spray
Yeah,
dryer.
very important.
So in UPM, the facilities about spray dryer, is there any type of dryer in UPM that
Um,
you can share to us?
we have one, but what we use it for drying of paddy, beras.
Yeah.
Uh, so that one is using a perforated rotary dryer. So it moves, yeah. So basically it dries the beras. Kita bukan panggil beras lah, kita panggil padi, the one with the rice husk. Yeah, so we dry our rice with the rice husk using a rotary dryer. We have that. We have freeze dryer. We also have vacuum dryer here. Other than that, I don't think anything else. I don't think we have anything else. Microwave oven, and that one is quite normal. We have the convective oven. Spray, freeze, vacuum, rotary dryer, but we don't have drum dryer here. Foam mat is quite normal. We use foam mat method to we produce nangka powder, jack powder. We have done on durian powder and also coconut water powder using a foam mat method.
Yeah. Oh, many facilities in UPM, but in Unpad we have only a few.
It's okay.
So
I think we need to invest on a smaller equipment. I think drum dryer would be big. Spray dryer is too expensive. Maybe we can start with infrared. Yeah, we also have infrared dryer. Infrared dryer is we just fabricate. We made it our own. So we use a conventional dryer and we put in infrared lighting inside. So yeah, just for assisted infrared drying. So we have that. But
what material you tried using infrared dryer? Is it
try
herbs?
herbs, yeah.
Herbs. Oh.
So usually leaves of our herbs that we want to try, we use infrared drying. Microwave not so much because of the hot spot. Infrared is quite good, but I think that one and you can do it on your own. Because we did it our own. We just fabricate using a conventional oven only. Okay.
Yeah. Yeah.
But other than that, freeze drying is a bit expensive. We got that. But our equipment here, although it's expensive, it's a bit old because we bought that during like 10, 15 years ago when Malaysia had a lot of money. At that time, now the budget is a bit small, I guess, because of inflation and the COVID and everything. So our equipment has not been replaced yet. So we still have a bit an old version of the technology, but it's there lah.
Okay, okay. Thank you, Dr. Nadiah, for the insight. I think I'm interested with infrared dryer. Perhaps
Infrared
I have to
is
have
uh,
to learn about how to design the circuit.
I hope you can come to UPM someday, then we can go into our laboratory tour.
Yeah, thank you for the invitation. Okay, Dr. Nadiah, because the time is 11:39 ya, I think we have over the class. Teman-teman mahasiswa, can we take documentation for this class? Silahkan dibuka camnya. Silahkan. Sudah semuanya atau belum? Oke ya, semuanya. Oke, Dr. Nadiah, we will take documentation. Please, 1, 2, 3.
Thank you, everyone.
Thank you, Dr. Nadiah. Perhaps we
See you
can
next week.
see you next week. And thank you for all the material and for your sharing today. Mahasiswa, jangan lupa minggu depan masih dengan Bu Dr. Nadiah, 2 minggu ke depan. For the presentation, it will be on the third or the second session, Dr. Nadiah? The third, oke. Jadi di pertemuan yang terakhir nanti akan ada presentasi, akan kami bagi menjadi kelompok-kelompok kecil. Seperti itu ya. Terima kasih. Kita akhiri. Assalamualaikum warahmatullahi wabarakatuh. Thank you again, Dr. Nadiah, for your sharing and explanation.
Thank you, Dr. Nadiah.
Thank you.